Hey everyone, welcome to This Explainer. I am absolutely thrilled you're here today because we are going to be looking at something truly fascinating. Did you know that a single second of your recorded voice contains over 2,000 distinct data points? Crazy, right? Today, we're exploring the incredible convergence of that human voice analysis and open source acoustic technology. Think of this whole explainer as a journey following a ripple of sound. We're going to start right at the epicenter with the human voice and then expand outward to the absolute boundaries of global acoustic science.
Okay, let's dive into this. We're going to move pretty fast, starting with voice as a biomarker, then exploring bioacoustic biology, and checking out the open-source soundscape. After that, we'll cover practical acoustic tools for both beginners and advanced users, before wrapping up with some predictions on the future of sound.
All right, Section 1, Voice as a Biomarker.
You know, we usually just think of our voice as a tool for everyday speech, how we order coffee or chat with friends. But it is actually this incredibly dense, rich package of data. And the medical establishment is finally starting to truly listen to it. To ground ourselves, let's just define what we're talking about here. A vocal biomarker is a specific signature, or even a combination of features from the audio signal of your voice that is linked directly to a clinical outcome. And modern artificial intelligence and natural language processing, well, they've completely revolutionized this space. They make tracking these tiny microscopic vocal nuances scalable, affordable, and just highly precise.
And this brilliantly illustrates how it actually operates in practice, flowing straight from everyday smartphones and voice assistants right in your living room all the way through to actual clinical practice. This kind of setup enables remote monitoring, digital interventions, and it really augments your interactions with healthcare professionals completely seamlessly. You don't even need to step foot in a hospital.
So what can we actually detect just by listening? It's honestly mind-blowing. We're talking about targeted analysis for neurodegenerative diseases like Alzheimer's and Parkinson's. We can track mental health states, including stress and depression, and even cardiometabolic diseases and COVID-19. This proves, beyond a shadow of a doubt, that the voice is this rich, completely non-invasive window into our physiological and psychological states.
Moving on to Section 2, Exploring Bioacoustic Biology. Let's transition to the first major echo of this science. We're going to look at the pioneering, albeit proprietary work of Sherry Edwards and the Institute of Bioacoustic Biology. Let's break down the mechanics of her alternative model. Basically, it treats your voice like a giant frequency map of your entire body. It uses voice spectral analysis to flag any unusual peaks or gaps in your vocal frequencies. Then, these anomalies are matched against a proprietary internal database of what they call frequency equivalents. Finally, it forms a closed-loop system by applying low-frequency sound tones back to the user. The goal here is to influence symptoms based on these math-based biomarkers.
I absolutely have to highlight this quote because it perfectly encapsulates their core philosophy. Sherry Edwards says, "People can lie with their words, but the frequencies of your voice will tell on you." It really emphasizes the belief that there's this inherent, inescapable truth found directly in the acoustic frequencies our bodies emit.
Now, if you're wondering how this is applied in the real world, the Sound Health Portal actually operates active campaigns offering completely free voice analysis for specific conditions like PTSD, cellular inflammation, and Parkinson's. It serves as a really practical, direct entry point into Edwards' proprietary methods, letting everyday people seek out feedback on their own personal wellness.
All right, let's shift gears to Section 3, the open source soundscape.
We are now pivoting to the amplification phase of our acoustic ripple. Now, what's really interesting about this is the stark contrast in approaches. On one hand, you have proprietary bioacoustics. These rely heavily on closed-loop portals, internal fixed-frequency tables, and a primarily alternative health focus. But on the flip side, we have the open-source bioacoustics movement. This side thrives on collaborative GitHub ecosystems, fully transparent algorithms, and highly testable deep learning models. By sharing data out in the open, these groups are rapidly accelerating discovery across clinical science and global ecology.
And honestly, this open-source collaboration, it is absolutely critical right now because of something known as the acoustic data deluge. We have digital recording devices everywhere, capturing continuous audio in all sorts of environments around the clock. This 21st century data deluge absolutely demands deep learning and AI to automate workflows. We need powerful, scalable software like Open Soundscape to manage and process millions of hours of audio, because human analysts could simply never analyze all of that alone.
Here is a prime example of that open source power in action. Google and QUT launched the A2O search tool. It's an open source AI engine that allows researchers to literally search through millions of hours of Australian wildlife audio in seconds to monitor ecosystem health.
It is so incredibly advanced that it can even distinguish between adult and juvenile bird calls just to track population survival rates. Seriously, it's mind-blowing technology.
Which brings us to Section 4, Acoustic Tools for Beginners.
Let's direct our attention right back to you. How can you catch this acoustic wave and start experimenting immediately? Well, here are some incredibly accessible options. If you want a web-based, alternative look into personal voice wellness, the Sound Health portal is a great place to start. If you want to engage in citizen science right from your mobile phone, check out the BirdNet Live app. It lets you record and identify local bird sounds with super high precision. Or if you're curious about the noise levels in your neighborhood, the Noise Capture app lets you map community environmental noise. You can become an active citizen scientist today just using the smartphone in your pocket.
Let's move to Section 5 and see how this builds into advanced bioacoustic systems. Now for the advanced users out there, those of you with some coding experience who want to really get your hands dirty, there are some incredibly powerful open-source repositories and hardware setups available. You've got Akoupi and Python for deploying AI models right on edge devices. PyRoom Acoustics is brilliant if you're modeling room environments. If your research takes you underwater, PamGuard in Java detects marine mammals. And of course, hardware like the Raspberry Pi allows you to build low-power, real-time acoustic monitoring systems out in the field.
And I really want to highlight why this specific hardware integration matters so much. It is entirely about democratizing science. Think about it. Solar-powered Raspberry Pi edge devices, equipped with basic microphones and wireless messaging, are making advanced acoustic research highly accessible, particularly in developing countries. These low-cost, open-source systems drastically lower the financial and technical barriers to entry. They're empowering global researchers to track their own ecosystems.
Of course, for scientists needing exact, high-frequency biological data, there has to be a bridge between specialized hardware and software. That's where something like Avisoft Bioacoustics comes in. They provide lab-grade equipment tailored for everything from bat echolocation to high-frequency ultrasonic vocalization recording in rodents. Their hardware perfectly integrates with their SaaSLab Pro software, creating this really robust ecosystem for deep behavioral and neurophysiological studies.
Finally, Section 6, the future of sound.
So, we've explored the epicenter of voice and the expanding waves of open-source technology. Now, let's extrapolate exactly where this is heading. The crucial point is looking at the distinct trajectory we're on. We started back in the 80s and 2000s with manual listening and early proprietary frequency tables. Then, the last decade brought us open-source AI and remote edge computing. And as we project into the 2030s and beyond, we are heading straight toward hybrid health models and predictive acoustic diagnostics. Very soon, your voice is going to act as a multimodal health signal sitting right alongside your smartwatches and routine lab work.
And honestly, this technology is going to expand way beyond just personal diagnostics. It's going to integrate seamlessly into the spaces around us. Just imagine sound-responsive environments. Think about that for a second. In the near future, smart systems will listen passively, instantly inferring human stress, fatigue, or agitation just from the microfluctuations in your voice and ambient noise. They will then automatically adjust the lighting, change the ventilation, or trigger helpful interventions. Our physical spaces are going to become dynamic, literally reacting to the acoustic ripples we constantly emit. Which leaves us with this final, incredibly provocative thought. As acoustic intelligence becomes a seamless part of our physical environment, how will your voice interact with the smart, listening spaces of tomorrow? It is such a fascinating frontier, and the best part is that the tools to start exploring your own acoustic footprint are already waiting for you. Thank you so much for joining me for this explainer. Stay curious and keep listening closely.